Imagine a digital replica of a physical device, a meticulously crafted virtual twin that mirrors every detail and function. This is the essence of digital twins, which serve as powerful tools for simulation, monitoring, and maintenance. Picture a sprawling factory, where digital twins continuously analyze data from machines, ensuring optimal performance and predicting failures before they occur. In the automotive industry, envision a sleek car model mapped digitally, where every engine component is tracked and optimized in real time. Digital twins revolutionize vehicle design and testing, allowing engineers to assess changes without the hefty price tag of physical prototypes. This virtual realm becomes a sandbox for innovation, where every tweak can be assessed for efficiency and performance, far faster than traditional methods. Now, shift your focus to urban planning, where sprawling city designs come alive in digital format. A city planner can simulate traffic patterns and infrastructure resilience using digital twins, predicting how changes will affect the urban landscape. Imagine adjusting traffic signals, observing pedestrian flow, and estimating environmental impacts, all within a virtual environment that saves both time and resources. The operation of digital twins hinges on sophisticated data integration from physical devices. Through sensors embedded in machines or systems, real-time data is relayed to their digital counterparts. This dynamic relationship empowers businesses to react swiftly to potential issues, making adjustments proactively rather than reactively, ultimately enhancing operational efficiency. The benefits for humanity extend beyond mere efficiency. By optimizing manufacturing processes, companies can reduce waste, leading to more sustainable practices. In the automotive industry, digital twins foster innovation while enhancing safety, providing a safer driving experience. In urban environments, they enable smarter city planning, creating spaces that are more livable and ecologically friendly. Imagine bustling neighborhoods designed with optimized resources that cater to both community needs and environmental sustainability. As digital twin technology continues to evolve, its impact is set to grow exponentially. Industries will witness reduced downtime, lower maintenance costs, and heightened performance across the board. This virtual semblance not only bridges the gap between the physical and digital worlds, but also holds the potential to revolutionize how we interact with technology. The future is bright. Enabled by the sophistication of digital twins, we can anticipate and mitigate challenges before they manifest, thus enhancing quality of life. Digital twins are transforming industries by providing a virtual mirror of physical assets, systems, or processes. This innovation offers businesses a powerful tool to simulate and optimize performance, paving the way for enhancements that were previously unimaginable. As companies embrace this technology, they unlock the potential to monitor operations in real time, enabling proactive decision-making that significantly reduces costs and increases efficiency. In manufacturing, digital twins take center stage by simulating production lines. These virtual models reveal detailed insights into workflows, helping organizations streamline operations and minimize downtime. When a sensor detects an anomaly, predictive analytics can forecast potential equipment failure before it disrupts production. Such foresight not only cuts costs, but also boosts product quality by maintaining consistent operational standards, leading to higher customer satisfaction. The automotive industry also benefits immensely from digital twins. Manufacturers use these replicas to conduct rigorous performance testing under varied conditions. This approach allows for the optimization of vehicle design and the evaluation of new materials prior to assembly. Furthermore, real-time monitoring of vehicle health empowers manufacturers to implement predictive maintenance strategies. This proactive stance mitigates safety risks, ensures smooth operations, and extends the longevity of vehicles. In urban planning and smart cities, digital twins are utilized to engineer better living environments. City planners can simulate infrastructure to optimize resource allocation for energy and water systems. Utilizing data-driven insights, cities can foresee the repercussions of new developments or changes and manage traffic flow more effectively. It's a forward-thinking approach that aims to create sustainable, efficient urban spaces, enhancing the quality of life for residents. Healthcare is another sector experiencing a digital transformation through twins. Virtual models of individual patients allow medical professionals to predict treatment responses by first simulating various interventions. This method not only personalizes care, but also contributes to more efficient hospital operations by optimizing resource use and enhancing patient flow. Through simulations, healthcare providers can better allocate resources, ensuring timely and effective treatments. In the energy sector, digital twins help to monitor and optimize power plants, predict energy demand, and efficiently manage energy distribution across grids. For instance, digital twins in wind farms adjust turbine performance by analyzing real-time wind patterns. This technology fosters an adaptable, efficient energy infrastructure that can meet fluctuating demand seamlessly. Overall, the integration of IoT sensors and analytics within digital twins empowers organizations to understand and manage complex systems, enhancing decision-making and operational effectiveness.